picture this scenario because I think it really says so much about how we live right now.
Oh, absolutely. I'm ready.
So you are driving in a completely unfamiliar city. It is pitch black outside. The rain is just coming down in sheets.
Yeah, the absolute worst possible driving conditions.
Exactly. And you are relying entirely on the GPS glowing on your dashboard.
Right, because you can't see a thing out the windshield.
Exactly. So the screen with its, beautiful high-resolution interface and that perfectly calm, polite voice, it tells you to turn right in 500 feet.
And you obey.
You obey, you turn right. But as your headlights kind of sweep across the road ahead, the light doesn't reflect off wet asphalt.
Oh, no.
No, it reflects off a boat ramp.
Yeah.
And then water, like a massive dark lake.
Wow. Okay.
Now, in that moment, your lizard brain, your physical eyes, and like millions of years of deeply ingrained evolutionary survival instincts are all just screaming at you, right? They're saying, stop the car, that is a body of water.
Of course. I mean, physics is literally staring you in the face.
But the screen, the highly calibrated, satellite-linked screen is completely unbothered. It cheerfully suggests you continue straight for 2 miles.
The terrifying part of that scenario isn't even that the technology glitched, honestly. No, the truly terrifying part is how many of us would actually hesitate in that moment.
Yeah.
Like we'd look back at the screen and seriously consider hitting the gas.
Yes, we really would. And that is the exact tension we are exploring today. It's this hilarious but honestly deeply unsettling modern phenomenon.
It really is unsettling, yeah.
We have reached a point where we will actively question our own physical senses if a digital dashboard confidently tells us otherwise.
Right, because we sit there staring at the water thinking, well, the satellite is in space.
It must have a better view.
Exactly. It must know better than I do.
Oh.
We are completely deferring to the representation of reality over reality itself.
And that collision between digital arrogance and physical reality is the foundation of today's deep dive. We are unpacking a phenomenal stack of sources today.
Yes, this is a really rich set of materials.
It's a multi-platform editorial series called Field Note number 005, and it's part of this broader ongoing project focused on what the authors call restorative engineering.
Which is such a fascinating term, restorative engineering.
It is. We are going to be looking at essays, operational threads, and some incredibly detailed industrial design prompts that all kind of circle around this one central, highly disruptive idea.
A very necessary disruption, I'd say.
For sure. So our mission over the next hour is to completely redefine what the word intelligence actually means.
Right. We're taking it back to basics.
We are going to strip away the modern obsession with, raw processing speed and massive data collection.
And look instead at the quietly profound, rapidly disappearing art of human attention.
Yes. Because it is a necessary reevaluation. I mean, we live in an era that is completely intoxicated by data accumulation.
We really are. The prevailing logic everywhere, especially in tech, is that if we just capture more parameters, and if we process them faster and feed them into a larger context window, we will eventually synthesize omniscience.
Like we can just build a god out of spreadsheets.
Exactly. But these sources argue that in our rush to collect every conceivable data point, we have entirely forgotten how to notice what any of that data actually means.
Right. And to be clear for everyone listening, the texts do not present an anti-technology manifesto.
No, not at all.
Nobody is suggesting we smash the servers or go back to the Stone Age.
No, this is a fascinating exploration of human capability in the gray areas where algorithms just haven't yet learned to look.
Yeah, that's a great way to put it. So I want to ground this for you, the listener. Take a second and just picture someone specific in your life.
Everybody knows somebody like this.
Think about the most experienced, quietly competent person you have ever shared a workspace with.
The veteran.
Yeah, that veteran who never seems rushed, but somehow just knows when something is about to go wrong long before the software sends out an alert.
They just have that sixth sense.
Exactly. So by the end of this deep dive, we are going to dissect the exact cognitive mechanics of why their brain works that way.
And I promise you, it has absolutely nothing to do with them having a faster processing speed than you do.
Not at all. So the best place to start dismantling our current definition of intelligence is at the exact origin point of this Field Notes series.
Right. And the authors don't place us in a sanitized robotics lab.
No, or some Silicon Valley venture capital meeting. They drop us into a remarkably ordinary, loud, and physically demanding environment.
A factory floor.
A factory floor. So let's walk into that factory for a minute. The text describes a typical Tuesday morning on a high-volume production line.
Just a completely average day.
Completely average. Everything is running flawlessly. If you look up the massive digital dashboards hanging over the floor, every single metric is radiating success.
All green across the board.
All green. The cycle times are optimized. The machine utilization rates are hovering in the high 90s.
Right. The thermal sensors are reporting temperatures well within the safety margins.
Exactly. The source uses a great phrase here, actually. It notes that if the production dashboard were a person, it would be leaning back in its ergonomic chair with its feet up on the desk, feeling incredibly smug.
That's such a perfect image. The interface is just projecting absolute serenity.
Yeah, it's so proud of itself.
Because it's doing exactly what we designed it to do.
Right.
It's collapsing the massive complexity of thousands of moving parts into a simplified visual summary.
Right.
A summary that basically tells the room, everything is predictable and you are safe.
But then reality gets a vote.
Reality always gets a vote.
It really does. So an experienced maintenance operator happens to be walking past this perfectly functioning line.
And he isn't rushing.
No, he isn't holding a tablet or checking a diagnostic app. He is literally just walking to get a coffee.
It's just a normal Tuesday morning coffee run.
But as he passes one specific gearbox, he stops. And the source emphasizes this detail. He doesn't touch the machine, and he doesn't look at a screen.
Right.
He just tilts his head and listens for about 3 seconds.
3 seconds. That's all it takes.
Yeah. Then he walks over to the maintenance desk and calmly requests that they pull that specific gearbox off the line and inspect it before the lunch shift.
And the critical data point in this anecdote is what the sensors were doing during those 3 seconds.
Right. What was the dashboard saying?
Well, the vibration monitor attached directly to that gearbox had not crossed its alarm threshold. The thermal couples showed absolutely no spike in heat.
Wow.
Every single key performance indicator remained solidly in the green.
But when the maintenance crew reluctantly opened the
The
housing...
gearbox was quietly, methodically tearing itself apart from the inside.
Oh, man. Physics politely sided with the operator. That line from the text is just brilliant.
It really highlights the blind spot, doesn't it?
It totally does. The museum-quality million-dollar dashboard completely missed the story, and the guy with the lukewarm coffee caught it.
Right. And we really have to unpack the mechanism of that failure. Why did the multi-million-dollar monitoring system miss a mechanical failure that a human being caught just by walking past?
Yeah, what's the difference there?
The answer lies in the fundamental difference between processing and discernment. The digital monitoring system was executing an algorithmic checklist.
Like a script.
Exactly. It was asking a rigid set of pre-programmed questions like, is the vibration frequency below variable X? Yes. Is the temperature below variable Y? Yes.
So it's executing computation flawlessly.
Flawlessly. But the human brain in that moment was doing something structurally different. The human wasn't checking a list.
Right.
The human was evaluating the entire environmental context.
Okay, so if I can try to reverse engineer the engineering logic here for a second.
Go for it.
My immediate thought reading this was about calibration. Like, if a gearbox is failing, the physical reality is that it is vibrating in a destructive way, right?
Yes, it's making noise.
Right, so if the human heard it, there were acoustic waves in the air. Why isn't the solution simply to buy a more sensitive microphone, lower the alarm threshold on the sensor, and capture the data?
That's what everyone asks.
Right. Doesn't a tighter parameter just solve this entirely?
See, that is the exact instinct of every software developer and systems engineer when faced with an anomaly. Fix the parameter, add a sensor, capture more data.
Right. Just patch the system.
But this is where the sources introduce a major philosophical roadblock. Physical systems, whether it's a mechanical gearbox, an ecosystem, or even a human body, they rarely announce the exact moment they begin to degrade.
They don't just snap overnight.
No, they don't suddenly jump from perfect health to catastrophic failure in a straight line. They whisper first.
They whisper. I love that.
And a sensor is entirely limited by its imagination, or rather, the imagination of the person who programmed it. It only knows how to listen for the specific dialect of failure it was explicitly taught.
So, like, a vibration sensor only understands amplitude, for example. It just knows loud or quiet.
Precisely. You could lower the threshold for loud, but what if this particular failure doesn't manifest as louder?
Oh, wow. Okay.
What if, as the metal begins to fatigue, the amplitude stays exactly the same, but the pitch shifts by half an octave?
Right. The sensor wouldn't care about pitch?
Exactly. Or what if it's a harmonic resonance that only occurs for a split second every 14th rotation? A sensor is totally deaf to anything outside its assigned vocabulary.
So the dashboard only speaks the language of its programming.
Yes, but the operator has learned to listen to the space between the sensor.
The space between the sensors, that paints such an absurd, almost theatrical picture of the modern workplace.
It's very comedic in a dark way.
It really is. You have this massive glowing screen proudly declaring to management that efficiency is at 100%. And meanwhile, a guy in a faded polo shirt is quietly putting a red lockout tag on a machine to stop it from exploding.
It's exactly that meme of the dog sitting in a burning room saying, "This is fine."
Yes, the computer is the dog in the meme. It's funny because it's a dynamic we see everywhere now, not just in factories.
And the absurdity of that image is the foundational critique of this entire series.
Yeah.
Because the dashboard failed so spectacularly in that moment, the authors force us to interrogate why we have built an entire global economy around deferring to it.
Which leads us directly into a fairly rigorous dismantling of how the tech sector, specifically Silicon Valley, currently defines intelligence.
Right. And I think we need to define some of the jargon, the sources critique here, because it gets pretty thick.
Yeah, let's break it down. When we talk about the current AI arms race, the text points out that the industry defines progress purely through the lens of scale.
Right. Everything's about getting bigger.
Exactly. Companies are constantly boasting about having larger models with more parameters. Now, for anyone not deep in machine learning, a parameter is essentially a mathematical dial.
Like a weighted connection inside an AI model.
Right. And the assumption is the more dials you have, the more complex the patterns the AI can mimic.
And we are also seeing this intense competition over inference speed, which is basically how quickly the model can generate an answer or predict the next word.
The reflexes.
Right, in context windows, which you can think of as the AI's short-term working memory. Like how many pages of a book can it hold in its head at one time before it forgets the beginning?
Right. So the entire metric of success in Silicon Valley right now is more dials, faster reflexes, bigger memory.
Yes.
It's this relentless, brute force pursuit of volume.
And the author doesn't dismiss these achievements, to be fair. Having a massive context window and lightning-fast inference speed produces incredibly powerful tools.
Right. They are genuinely impressive.
They are. But the authors make a vital distinction that we have collectively lost sight of. We've started confusing computation with intelligence.
Ah. Computation versus intelligence.
They are related concepts. They often operate in the same spaces, but they are not the same thing.
Okay, so if I'm following the logic of the text here, computation is the ability to crunch the numbers provided to you. It's like answering the test questions correctly and quickly.
Yes. Computation answers questions efficiently. But intelligence, true, adaptable intelligence, is noticing the question that nobody in the room thought to ask.
Wow, okay, I see. Because the dashboard was doing brilliant computation.
Phenomenal computation.
It was crunching the vibration metrics thousands of times a second, but it couldn't ask, does this sound slightly more metallic than it did on Thursday?
Exactly. Let's look at the sheer volume of data on a modern factory floor.
It's massive.
You have optical sensors, thermal imaging, pressure gauges, torque monitors, cycle timers, all feeding into a central database. The human engineer is not lacking information.
If anything, they are drowning in it.
Exactly. The system can provide a hyper-accurate answer to almost any question you query it with. But what the human operator brings to the table is something algorithms struggle deeply with.
And what's that?
The act of omission.
Omission, the ability to just ignore things.
Yes. True intelligence in a data-rich environment is an editorial function. It is knowing which flashing light actually deserves your attention and which anomaly is just harmless statistical noise.
Right.
It is knowing which high-pitched whine doesn't belong in the acoustic profile of the room. The experienced engineer isn't a supercomputer processing a million variables simultaneously.
Right, they'd go crazy if they tried to do that.
They are a master editor who has learned what can be safely ignored.
Okay, let me push back on this a little bit, because this flies in the face of modern corporate dogma.
Oh, absolutely it does.
I mean, we are constantly lectured that data is the new oil. The entire premise of big data is that more information inevitably leads to better insights.
That's the sales pitch, yeah.
Right. If you just collect every single data point, dump it into a massive data lake, and run an algorithm over it, the ultimate truth will supposedly reveal itself. But it sounds like these sources are arguing that collecting less data, or at least focusing on less data, is the actual marker of intelligence.
That is a crucial fiction point. And the sources are careful to explicitly state that this isn't a zero-sum game between humans and machines or like a battle between big data and small data.
Okay.
They're structurally complementary. Think about the division of labor. The sensor is unparalleled at measuring, but the human technician is unparalleled at comparing,
So the software excels at observation and aggregation.
while the human excels at judgment.
Okay, so the danger isn't the data itself. It's our assumption about what the data does.
Precisely. The critical error we make is assuming that intelligence scales linearly with information. We mistakenly believe that if we feed a language model 10 times more text, or give a dashboard 10 times more sensors, it will organically become 10 times more intelligent.
Right, like volume equals wisdom.
Exactly. But if you spend any time on a factory floor, you realize that true expertise rarely announces itself as speed or data volume. True intelligence usually manifests as restraint.
Restraint.
It is the hard-won ability not to react to every single fluctuation.
Because if you react to every single data point, you aren't being intelligent, you're just being frantic.
Yes, exactly.
You're a golden retriever in a room full of tennis balls. You're constantly chasing noise, which raises the most fascinating question of this entire text for me.
What's that?
If true intelligence isn't about processing power, and it's instead this highly selective, almost intuitive judgment, how does a biological human actually acquire that?
Right, you can't just download an update into a human brain.
Exactly. So how do we get there?
Well, the author tackles that exact question through a really innovative format. Part of the Field Note project includes these conceptual prompts for short films.
Which is such a cool way to present this.
It is. They're designed to visualize these abstract engineering philosophies. The second film prompt in the series is titled 10,000 Ordinary Days.
Which, as a movie title, sounds like an absolute endurance test for an audience.
It really does sound boring, but the title is the entire point. The thesis is that profound tacit knowledge, the kind of deeply ingrained, almost unconscious instinct that the operator used to catch the failing gearbox, isn't forged during dramatic crises.
Right, it doesn't happen in an emergency.
It isn't built by frantically taking notes while a machine is on fire. It is built upon a vast, unglamorous baseline of absolute boredom.
Boredom.
It is built through relentless, mundane repetition. Every single uneventful, ordinary day is quietly, invisibly teaching the operator's nervous system what normal actually feels like.
That makes total neurological sense. It actually reminds me of the experience of moving into an old, slightly drafty house.
Oh, that's a perfect example.
Right. For the first 2 weeks, it is a sensory nightmare. Every time the HVAC kicks on, you think a jet is landing, the house settles at night, and your brain instantly signals the roof is collapsing.
Because you have no baseline.
Exactly. The wind rattles a window, and you are convinced someone is breaking in with a crowbar. Your brain is processing every single input as a potential critical anomaly because it just doesn't know what normal sounds like yet.
You are operating exactly like a poorly calibrated dashboard.
Yeah.
You are flagging every single sound as a red alert.
Yes, but fast forward 5 years, you don't even hear the HVAC anymore. Your brain has completely edited it out of your conscious awareness.
You omit it.
Right. And more importantly, you know exactly which specific floorboard in the upstairs hallway groans when someone steps on it. You know its exact pitch and duration.
So if it's 2:00 a.m. and you hear a footstep, you don't need to look at a security camera.
No. Without even opening your eyes, your brain processes the weight and rhythm of the sound, and you instantly know if it's just your dog wandering around looking for a comfortable spot, or if there is actually a stranger in your house.
That is a phenomenal analog for what is happening on the factory floor. You didn't sit in your living room with a clipboard, actively memorizing a spreadsheet of acoustic frequencies for every floorboard.
No, I didn't build a database.
You simply inhabited the space. For 10,000 ordinary days, your auditory cortex ran quietly in the background, absorbing the ambient data of your environment, building an internal, unconscious model of normality.
And the moment a sound violates that internal model, it cuts through the noise like a siren.
The author dictates a very specific visual metaphor in the prompt to explain this phenomenon. Imagine a static camera pointed at a complex industrial machine.
Okay.
Now imagine that every time a worker completes an ordinary, uneventful shift, a highly transparent overlay is laid over the lens.
Like a piece of film.
Right. One overlay is a hot Tuesday in July. Another overlay is a graveyard shift in December. Another is a day the humidity was high.
And individually, a single transparent overlay provides almost zero information.
Exactly. But when you stack 10,000 of them on top of each other, they compress into an incredibly dense, multidimensional, almost physical understanding of how that machine is supposed to behave under every conceivable condition.
That is such a striking way to visualize tacit knowledge. The anomaly stands out precisely because it doesn't align with the accumulated density of those 10,000 transparent layers.
And the author uses this to highlight a deeply relatable piece of observational humor about workplace dynamics.
Oh, this part is great.
They ask us to picture a brand new graduate engineer, fresh out of a prestigious university, standing in front of a production cell.
Basically, a kid.
Right. And this kid is practically vibrating with anxiety. He is holding a ruggedized tablet, frantically swiping between 12 different real-time graphs.
Desperately trying to correlate the vibration telemetry with the thermal output and the cycle speed.
He is drowning in parameters.
Yes.
He has all the data in the world and absolutely no idea what it means.
Exactly.
And while he's hyperventilating over a slight dip in a line graph, the veteran operator, who has been working on this floor since before the graduate was born, ambles over.
And the veteran doesn't look at the tablet?
No, he just stares at the physical machine for 2 seconds, sniffs the air, and calmly asks the room, "Did anyone remember to lubricate the primary drive yesterday?"
That is the most brutal kind of workplace humor because it is just universally true.
It really is.
The silence that follows that question is deafening.
It is the silence of 10 people with expensive iPads suddenly realizing they entirely forgot the foundational physical requirements of the hardware.
Right. The young engineer is paralyzed by the representation of reality on his screen, but the veteran operator is interacting with reality itself.
I love how this dismantles the hierarchy of information. We assume the person with the most complex dashboard is the most informed, but often they are the most distracted.
Which leads us to something I found genuinely fascinating in the text. How these masters of attention actually communicate.
Oh, their language, yes.
Because if you have this incredibly dense internal library of knowledge, you would think you'd need complex language to explain it.
But the sources point out the exact opposite.
Right. We are talking about the quiet language of restraint.
The authors observe that truly experienced operators almost never use dramatic, urgent language.
No, they don't sprint into the control room shouting, "Catastrophic systemic collapse of the tertiary gearbox is imminent. Sound the alarms."
No, because anyone speaking with that level of hyperbolic urgency is usually the person who just caused the problem,
Right.
or someone who hasn't been on the floor long enough to know what a real emergency actually looks like.
Exactly. The language of deep expertise is remarkably underwhelming. The text notes that a 30-year veteran will just tilt their head, look slightly annoyed, and say, "That machine sounds a bit different today."
Or they'll just mutter, "Let's have another look at that bearing."
Right. The author elevates that specific phrase, "sounds a bit different today," and calls it perhaps the most information-dense sentence in the entire field of engineering.
To an outsider, that sounds insane. Sounds different, sounds like a guess, it sounds vague, almost non-committal.
But the text highlights another sentence that carries incredible weight. When an experienced operator says, "It's probably nothing, but I'd still stop the line for 5 minutes just to check."
If you are a smart plant manager, when you hear those words, you hit the kill switch before they even finish the sentence.
You don't ask for a PowerPoint presentation. You don't ask to see the data. You just stop the multi-million-dollar line.
Because you know what that hesitation means.
I find the cultural contrast here so revealing because if you log into LinkedIn right now or if you listen to corporate earnings calls, the person who speaks the loudest, uses the most aggressive multisyllabic jargon, and projects the most unshakable confidence is automatically assumed to be the smartest person in the room.
We have built a white-collar culture that heavily rewards the theatrical performance of intelligence.
That's perfectly said, the theatrical performance.
We reward the appearance of complexity. We assume that if someone uses dense, impenetrable language, their underlying thoughts must be equally profound.
But the factory floor aggressively punishes that exact behavior.
It does.
A machine doesn't care about your vocabulary, and physics is completely immune to corporate buzzwords. The physical world rewards the person who notices the smallest, quietest physiological change in the system and communicates it with the least amount of fuss.
This dynamic leads to one of the most profound observations in the entire field note. It describes an inversely proportional relationship between mechanical failure and human expertise.
Break that down first.
The author notes, as physical systems begin to fail, they usually become louder, but as engineers gain experience, they usually become quieter.
That is a phenomenal insight. As the machine generates more noise, the expert generates less.
Think about it through the lens of information theory. Claude Shannon, the father of information theory, basically proved that reducing noise is how you increase the clarity of a signal.
Okay, right.
In the hands of an expert, language acts as the ultimate compression algorithm. The experience does all the heavy analytical editing before the person even opens their mouth.
Right. All that work is already done.
The thousands of hours of passive observation, the rapid processing of environmental variables, the instantaneous comparison against that internal stack of 10,000 transparent overlays, all of that invisible, complex labor happens in a fraction of a second.
And it is compressed, distilled down into 4 incredibly potent words. Something feels different today.
When you hear that, you aren't hearing a lack of certainty. You're hearing highly refined, heavily filtered judgment.
It's like they've pushed all the way through the complexity curve and come out the other side. They did all the complicated math 20 years ago, and now they just operate on pure distilled signal.
Precisely.
Now, we've spent a massive chunk of this deep dive on the factory floor talking about gearboxes and engineers, but one of the strengths of this text is that it insists this isn't just an industrial phenomenon.
Far from it. The author pulls the conceptual camera way back to demonstrate that this exact same mechanism of intelligence, this baseline of attention, is a universal law of human expertise.
It applies everywhere.
It spans wildly different professions and disciplines.
Let's explore some of those parallels. If this is a universal cognitive trait, how does the whisper before the alarm manifest in a totally different environment?
The sources offer several really compelling examples. Imagine a highly experienced cardiovascular surgeon in the middle of a complex procedure.
Okay.
The anesthesiologist is relaxed, the digital monitors are all steadily beeping, the vitals on the screens look perfectly stable, but the surgeon suddenly stops moving.
Why?
They pause because something about the physical rhythm of the patient's breathing or the tactile feedback of the tissue beneath their scalpel just feels wrong.
The digital representation of the monitors haven't caught the physiological drift yet, but the surgeon's hands have.
Exactly. Or consider commercial aviation. A veteran pilot is in cruise flight. The flight management computer is completely happy. No warning lights are illuminated.
Everything's fine on the dashboard.
But the pilot reaches up and adjusts the throttle slightly because they notice that the harmonic drone of the left engine simply doesn't sound quite right.
Ah.
The vibration hasn't crossed the threshold to trigger a cockpit alarm, but it has crossed the threshold of the pilot's internal baseline.
That is aviation's direct equivalent of the factory worker saying, let's just stop the line for 5 minutes.
It's the exact same instinct.
I imagine this applies to digital environments too, right? Even if there isn't a physical machine vibrating.
Absolutely. Think about a senior software engineer dealing with a massive cloud infrastructure incident. The server error logs might look absolutely identical to a routine crash they handled last Tuesday.
Right.
But the senior developer looks at the cascading failures and senses that the behavior of the system, the specific sequence of the timeouts, isn't matching the established pattern.
It feels different.
While the junior devs are furiously Googling the error code, the senior dev says, "Stop. This doesn't feel like a memory leak. This feels like a malicious attack."
Or even something entirely tactile and artisanal, like a master baker. The recipe in the book says to knead the dough in the mixer for exactly 10 minutes. The digital timer on the wall is ticking down from 10.
Right.
But the baker stops the machine at minute 7, touches the dough, and pulls it out.
They aren't looking at the representation of time on the clock.
No. They are feeling the physical reality of the gluten structure developing under their fingers.
And that is the common thread binding all these examples. The surgeon, the pilot, the software architect, the baker, none of them are demonstrating a superior capacity for rote memorization in those critical moments.
They aren't proving they have a faster computational processing speed than their colleagues.
What they are demonstrating is a vastly superior capacity for attention. They are noticing the deviation earlier. Biological pattern recognition is older, deeper, and often far more nuanced than artificial intelligence.
I have to bring up one more example from the text, because it is arguably the most universally understood proof of this entire concept, and it honestly made me laugh out loud.
I know exactly which one you mean.
The authors apply this engineering philosophy to the experienced parent.
Ah, the phenomenon of the suspicious silence.
Yes. If you want to understand tacit knowledge, look at a parent of young toddlers. An experienced parent is sitting in the kitchen. They have 2 3-year-olds playing somewhere in the house.
And suddenly,
Suddenly, the parent's brain registers a distinct change in the environment. The house has become completely, utterly silent.
uh-oh,
Now, if you are a teenager babysitting for the first time, silence is glorious. Silence is the goal. Silence means everything is peaceful and the kids are being good.
but to an experienced parent.
Complete silence is a glaring, flashing, catastrophic red KPI.
The author perfectly captures the physical reaction. The parent registers the total silence, slowly puts down their coffee mug, and immediately begins walking faster toward the hallway.
You do not enjoy the silence. Your internal library of 10,000 days with toddlers has taught you a fundamental law of physics. Toddlers are literally never silent unless they are actively engaged in a hostile takeover of the living room, or they have found a permanent marker and are quietly redecorating the dog.
It is exactly the same neurological mechanism as the factory operator.
It truly is. The dashboard of the house, the overall noise level, is reading 0.
And to an untrained observer, a 0 reading looks like perfection.
But the veteran operator knows that the absence of noise is, in itself, the most critical signal of all.
It is the pinnacle of pattern recognition. It is the ability to recognize which tiny, seemingly insignificant observation, even if that observation is a void, an absence of data demands to interrupt a perfectly ordinary day.
I really appreciate how the creators of this field note anchored such heavy philosophical concepts in situations that are so instantly recognizable. But I want to pivot our discussion to the final section of these sources.
Okay, yeah, let's do that.
Because the author didn't just write a series of essays, they actually generated incredibly precise visual instructions, master editorial image prompts, to dictate exactly how this philosophy should be visually communicated to an audience.
The visual direction is fascinating.
And looking at these prompts, it is an absolute masterclass in intentional design.
The author created a strict brief meant for an interdisciplinary design studio, and what stands out immediately is its rigid adherence to the philosophy of Dieter Rams.
Right. For our listeners who might not be deep into industrial design history, Dieter Rams is arguably one of the most influential designers of the 20th century.
His work for Braun in the mid-century heavily influenced the modern aesthetic of companies like Apple.
Rams championed 10 principles of good design, but his overarching mantra was less but better. Good design must be honest, it must be highly useful, it must be unobtrusive, and it should involve as little design as possible.
As little design as possible, which is the exact aesthetic equivalent of the experienced engineer using as few words as possible.
Right. The visual language mirrors the spoken language.
The prompt tasks the designers with an incredibly difficult challenge. Visualize the paradox of intelligence without using a single word of copy and without relying on any science fiction tropes.
So what does the prompt actually describe?
It describes an immaculate, museum-quality industrial production cell. The materials dictate a sense of calm-brushed aluminum, matte powder-coated steel, bathed in soft, natural daylight.
There are no sparks flying, no smoke, no dramatic red emergency strobes. It's a space of complete control.
Absolute control. And on one side of this frame, you have the dashboard. But it's not a chaotic jumble of dials. It is beautifully designed, heavily utilizing Swiss typography, think pristine Helvetica font, lots of negative space.
And every single indicator on that massive screen reads normal. It projects unshakable digital confidence. It is the absolute pinnacle of data collection and representation.
So that beautiful screen is the digital brain. It's the computation.
Right. How does the prompt instruct the designer to portray the human? Because if the machine looks so perfect, I would assume they want the human to look hyper-focused, maybe sweating, staring intensely at a schematic.
You would think so, but the instructions explicitly ask for the opposite. On the other side of the frame, standing next to a massive gearbox, is the veteran operator.
And what are they doing?
They are not frantic. They are not staring at a tablet or holding a wrench. They are standing perfectly still with their eyes closed.
Wow.
One hand is resting gently on the vibrating metal housing of the machine. And the key detail, they have simply reached up and removed one of their safety earplugs.
That is such a quiet, powerful image.
The symbolism is dictated directly by the text, and it is incredibly tight. The glowing dashboard representations are models of the world.
The massive gearbox represents reality, the physical world itself.
The human operator represents a tension that bridge between the two, and the vast, clean, empty space surrounding them in the composition. That represents everything we collectively fail to notice when we are rushing.
What I found just as revealing as the positive instructions were the negative constraints. The author explicitly lists what is forbidden in the artwork.
Oh yeah, the forbidden list is great.
They write, no humanoid robots, no glowing blue AI brains floating in space, no cyberpunk neon lighting, no cascading green binary code like the Matrix.
It is a total rejection of the current aesthetic of the tech industry.
Right, because we have this deeply ingrained cultural habit of visualizing artificial intelligence and intelligence in general as this glowing, magical sci-fi spectacle.
But the author is arguing that true functional intelligence doesn't look like a Ridley Scott movie.
True intelligence is profoundly ordinary. It is concrete, brushed aluminum, and natural light. It doesn't glow. It listens.
It forces the viewer to confront the difference between looking and noticing. There is a brilliant, subtle piece of visual irony baked into this prompt that engineers will instantly recognize.
Yeah, walk us through that.
Look at the composition of the image. The digital dashboard is actively monitoring hundreds of tiny, discrete data points, beautifully organized on a screen. But the human operator has their eyes closed, focusing their entire cognitive load on exactly one sound.
Just one sound.
The image looks at the viewer and quietly asks, which entity in this room is actually demonstrating intelligence?
The machine collected vastly more information, but the human recognized the only piece of information that actually mattered. The dashboard is shouting 1,000 things at once, and the operator is just listening for a whisper.
And that contrast encapsulates the ultimate thesis of Field Note 005. Intelligence is not merely the brute force capacity to answer complex questions quickly.
No.
True intelligence is the rare ability to notice which questions physical reality has quietly started asking us. It is a capability that is fiercely difficult to quantify. You cannot easily benchmark attention.
You cannot rank it on a leaderboard or sell it as a software subscription.
Exactly. But it is infinitely more valuable when your goal is keeping highly complex, fragile systems alive.
This entire deep dive has been such a massive paradigm shift. We have completely dismantled the Silicon Valley definition of intelligence as merely processing power and parameter counts.
We've really turned it upside down.
We've seen how computation can generate answers faster, but human attention generates better questions. We've explored how a baseline of 10,000 ordinary, boring days builds a neurological library of instinct that no dashboard can ever replicate.
And we've celebrated the highly compressed, beautifully understated language of genuine expertise. It sounds a bit different today.
If there is a final synthesis to draw from these texts, a core lesson to carry forward, it is this. The factory floor, the operating theater, the cockpit. These highly demanding physical environments didn't teach us how machines think.
They taught us how humans quietly become worthy of building and stewarding them. Digital systems will always be eager to provide us with data, and we should use it.
We definitely should.
But reality always, inevitably, gets the final vote. Good engineering, good medicine, good leadership, it all ultimately relies on learning to listen earlier.
That is a perfect summation. As we wrap up this discussion, I want to leave you with the field question that the author poses at the very end of these sources.
A great question to reflect on.
Think back to that highly experienced person you pictured at the beginning of this hour. The mentor, the veteran nurse, the senior mechanic. What is one specific moment where you witnessed their experience catch something long before the data could prove it?
Not because they had access to a better dashboard, but because they had cultivated better attention.
Hold on to that memory, because that is what actual intelligence looks like in the wild.
It's a vital question to reflect on, and if I may, I'd like to build on that foundation with a final provocation.
Oh, please do.
It is something not explicitly dissected in the text, but it is the inevitable looming shadow of everything we've discussed today. We have firmly established that true expertise, the kind of life-saving, system-saving attention we've been praising, is built entirely upon a foundation of 10,000 ordinary days interacting with physical reality.
It requires touching the dough, feeling the vibration of the bearing, hearing the creak of the floorboard.
It requires a physical baseline.
Exactly. So what happens to the next generation? What happens to the upcoming cohort of engineers, surgeons, pilots, and leaders whose entire baseline of normal is being constructed exclusively by looking at screens?
If a young engineer's 10,000 days are spent interacting with glowing representations of reality, rather than the tactile, vibrating reality of the machine itself,
If we slowly transition into a society that only knows how to look at dashboards,
will we entirely lose the biological ability to hear the whisper before the alarm?
that is a profound question to walk away with. Reality always gets the final vote. Thank you for joining us on this deep dive. Keep your eyes open, maybe take one ear plug out, and we will catch you next time.